Alright, so we're going to look at tessellations, which are basically shapes that could repeat infinitely that possess different kinds of symmetries that we've just talked about. So this is a tessellation which has translational symmetry, which means if you were to take this shape and shift it over to this shape, it's the exact same. Shift it over to this shape, it's the exact same. Shift it up, it's the exact same. Shift it down, it's the exact same. So there are a whole bunch of interlocking shapes that possess different kinds of symmetry. And so again, since translation is just shifting, this is a example that has translational symmetry. And how you create these is you start with something that has translational symmetry, like a rectangle. This rectangle, if I shift it left, is the same as this. If I shift it up, it's the same as this. If you shift it down, it's the same as this. So you start with an object that has the kind of symmetry you want, and then you would just create, if I were to put something that looks like a head for a horse here, then that would go up here, and that would go up here. And if you would put something that looks like a leg coming down, then that would come down here, and that would come down here. And we will look a bit more into that in just a moment. This object could be thought of as translational if I take these two objects together, because that just repeats over and over and over again. This is also one that could be thought of as glide symmetry, because this shape, if you reflect it and then shift it, could give you this shape. Now again, the way you would do this is to start with shapes that have glide symmetry. For example, this shape is the same as this shape is the same as this shape. And then if you were to reflect it, you would get this shape, which is the same as this shape, which is the same as just this shape. And if you start with something with that, you could then modify those shapes to create others. And again, we will look more into that in a moment. So here's a sample that's been done before that I found online, maybe by elementary or middle school age students. These are some other ones by M.C. Escher. These ones involve rotational symmetry. And so what you could do with rotational symmetry is start with something that has rotational symmetry. So if I look here, this has 1, 2, 3, 4 shapes. So if I wanted to think of something that has a fourfold rotational symmetry, I might start with something like a square, right? And so if I were to put something like this here, you rotate that 90 degrees, you get here, you rotate 90 degrees here, you rotate 90 degrees here, and you can start to create a tessellation that has fourfold rotational symmetry about a point. This, again, is another one which has rotational symmetry, right? If I were to choose any point and just rotate, you would see I have 1, 2, 3, 4, 5, 6 fold rotational symmetry, which probably means it started with equilateral triangles. If you make 6 equilateral triangles, it makes a perfect hexagon. And these shapes can keep repeating over and over and over and over again. And you end up with a whole bunch of interlocking triangles, which we will modify and see what we can do with that in a bit. So starting with translational symmetry, like the very first one up here. This is a quick example I just drew up. One of the ways you can do this is with a 3x5 card or a 4x6 card or just a square or rectangular sticky note. But let's see what we can do to create something with translational symmetry. So start with an object that has translational symmetry. And then what I do is, if I cut a shape out of the bottom, you can then tape or draw that same shape on the top. And so a lot of times these are great classroom projects because you can actually remove something from the bottom, cut it out, put it on the top, and then we end up with a shape like this. And now I'm going to do the same thing. If I were to take something off the left, I would then put it on the right. And so what I did here, you could do that multiple times. I could cut something in here, put it over here, cut something in here, put it over here, cut something in here, put it over here, cut something in here, put it over here. And so that is what I did in this shape. Is I did something more of a zigzag in and out, and then that exact same zigzag in and out went to the other side. Exactly the same so that they line up. And so I went in, out, in, out, in, out, and I moved that exact same shape over to here, and you can go piece by piece or all at once, depending. And then you end up with this shape that has the kind of symmetry you're looking for. And now one of the next things you could do is if you're going for something more interesting or creative, you know, you could try to turn it into design. I just really quickly put some eyes on it to make it look like a fox. And now if you're doing this on a note card, you should have this shape on a note card, and you can just lay it out and trace and trace and trace and trace. Since I just did this on my iPad, I just copied and pasted this shape over and over and over and over again, and you have some sort of translational symmetry picture. Now, for rotational symmetry, again, if I'm going to choose, I need to start with an object that has the rotational symmetry I want. And now this thing, if I wanted to come up like this, if I rotate 90 degrees, it would look like this. And rotate 90 degrees, it would look like this. And rotate 90 degrees, and it would look like this. But the whole thing can't rotate around one point. It would also need to rotate about this point. So if you rotate that up 90 degrees, it would look like this. Rotate it down 90 degrees, it would look like this. Rotate again 90 degrees, it would look like this. And I would also want it to rotate about this point. So if you rotate this down 90 degrees, it would look like this. And if you wanted to rotate over this, if you rotate that up 90 degrees, it would look like the thing we want. And so bit by bit, you can start rotating all of these shapes about all of the points. And we would get this picture. Let's see, if I rotate that up 90 degrees, it would go like that. If I rotate that up 90 degrees, it would go like that. If I rotate this up 90 degrees, it would go like this. And so if you were just to draw a shape on one side and then rotate that shape 90 degrees about all the other vertices, it would start to create this rotational symmetrical design where we have a fourfold rotation about any single vertex, any single corner of our original squares. Now what we're going to do for the majority of this next part is work on something which has a sixfold rotational symmetry. So we start with equilateral triangles. All sides are the same length. All angles are the exact same, and they're all 60 degrees. They can stack up nicely to make regular hexagons, and you can keep stacking them forever and ever and ever. So to do this, I'm going to have to cut out of this PDF for just a second and switch videos. So let's stop this one. All right, moving to this one. So the steps in creating this are: start with equilateral triangle. And again, these equilateral triangles can stack up a whole bunch over here, right, on top. So could be rotational symmetry about this point, about this point, about this point, about this point. We can have rotational symmetry about any point. Now, the way you do this is you draw some shape on the left and you rotate that over to the right. So that's what I did here. Now again, if you're going to build this or construct it, you could start with a equilateral triangle on a piece of paper, and you can even cut in to your triangle on one side and then take that piece and tape it on to the other side. Now the next thing you're going to do is to take the bottom of your triangle and cut it in half, and what you cut up here, you are then going to rotate 180 degrees around that point and put it down here. But one step at a time. So step one, I did this stuff right up here, moved the stuff from the right to the left, and then I erased these extra outside lines, and this is my new shape over here at step number 3. Now if I cut up here and I take this shape and put it down here, so what I did for that one is I didn't do a round hump. I said, hey, let me make, some sort of pointy shape coming up, rotate that 180 degrees, put that piece down here, and now if I erase those lines, I now have this shape right here at step number 5, which should have all the rotational symmetry I want. And so I started to copy and paste and put these things together. And so, you can see here I've got 1, 2, 3, 4, 5, 6 around this point. Or right here I should have 1, 2, 3, 4, 5, 6 around this point. I didn't do this forever and ever and ever. I just started to copy and paste some of them in there. But then if you wanted, you could then create this thing even further, make it more interesting. If you see some sort of shape on there, you could then make some sort of weird design. This looks sort of like some weird fish. Or if you want, you could see what other picture you see in there, and then when you come back to your design on the bottom, you could draw that, and you'd have a whole bunch of fish all twisted up together, or whatever it is you want to draw. But that is how we can make a six-fold rotational symmetrical tessellation starting with equilateral triangles. Right? That is it.